Alright, in this problem we are going to look at projectile motion when a ball is thrown straight up in the air. So here our problem says a tennis ball is thrown straight up in the air with an initial speed of 19.8 meters per second. And we want to find out how high it went. So once again, we look to the problem solving process and we write down the variables provided and what we're looking for. So first off, we want to know in the end, how high did it go? So it's change in position. So here we're going to say, in the end, we're looking for delta x. Even though we're in the vertical position, we're just going to call it x to keep all our variables together. Now, here they only give us an initial velocity. So VO is going to be 19.8 meters per second. Now this problem's a little tricky because even though they don't say it or written, we have to find out what our velocity is right at the top, because we have to find out how high it went, and when it reaches its maximum height, its velocity in the air in the vertical position is going to be 0. So we can write down that our final velocity is going to be 0 meters per second as well. Now, if we look at the equations provided, if we're looking for x, there's no x in the top one. Here I have an x, but I don't have a time, and there's other options that I don't have that I need. Here I have an x, I have an acceleration, an initial, and a final velocity, and here that's no help at all. So I think what I need to do first is to solve for how long the ball is in the air. And to do that, I'm going to go back up to my top equation. So this v over here is referring to our final velocity. Even though it's not written on there, it's saying our instantaneous velocity, or our velocity at that moment. So we're going to write Vf is equal to Vo plus acceleration times time. We're going to solve for t here. So since our final velocity is 0, this is going to work out to VO, or negative VO, is equal to acceleration times time. Now we just plug in our values. So we say negative 19.8 meters per second is equal to, now acceleration is going down in this problem, so it has a negative value, 9.8 meters per second squared, times time. I want to get time by itself, so I divide both sides by negative 9.8, and in the end, t is equal to 2 seconds. So now I can take that variable and put it over here on my list. So now, still looking for x, but now I have time, and I have initial velocity, and my initial position is 0, so that goes away, which allows me to now use the second equation to solve for what I was looking for in the start. So I say x is equal to VOT plus 1/2 a t squared. So this is the equation I'm going to use to solve for what I'm looking for. Now my initial velocity is 19.8 meters per second, so x equals 19.8 meters per second times 2 seconds plus 1/2. Now my acceleration is starting up, but gravity is trying to pull me down. So once again, gravity is going to be a negative 9.8, negative 9.8 meters per second squared times time, which gets squared. And when I start to solve for these values, over here I get 38.6 meters plus a negative 19.8 meters. So in the end, my max height, x, is equal to 19.8 meters. Now, just because my initial velocity and my final height are the same, that's just a coincidence, just so everything worked out nice and neat, and my time was 2 seconds. That's why I chose these numbers, but only in this case are those two numbers going to be the same and every other time you're going to get different values for those two. But this is a good two-step process problem for AP Physics.